Have you ever pondered the origins of our universe? What sparked its creation, and how did it expand into the vast cosmos we know today? These are questions that have intrigued humanity for centuries, driving us to look beyond our own planet and deep into the cosmos in search of answers. The Big Bang Theory, a concept that has fascinated scientists and non-scientists alike, offers intriguing insights into the birth and expansion of our universe. It's a theory that paints a picture of a time when all matter was condensed into a single point, which then exploded, giving birth to space and time as we know it. Science, with its relentless pursuit of truth, has played a pivotal role in uncovering the secrets of the universe's beginnings. From the meticulous observations of astronomers to the complex calculations of physicists, every discovery has been a crucial piece to the puzzle. Join us as we journey through time, retracing the steps of the scientists who have shaped our understanding of the Big Bang Theory. Our journey begins in 1965 with Arno Penzias and Robert Wilson's unexpected discovery of the cosmic microwave background radiation. This radiant energy, invisible to the naked eye, fills every corner of the universe. Imagine it as a faint echo of sound, a whispering hum that permeates all of space. Penzias and Wilson stumbled upon this cosmic whisper not by design but by accident. While testing a radio antenna, they detected a strange noise, akin to a low, steady, mysterious roar. This noise was omnipresent, unyielding, and remarkably uniform. This was not just random interference, but the first detection of the cosmic microwave background radiation. So why is this important? Well, this discovery was monumental. It was like finding the universe's baby photo. The cosmic microwave background radiation is the afterglow of the Big Bang, an echo of the intense heat that filled the universe moments after its birth. It's our clearest snapshot of the universe when it was just 380,000 years old, a mere infant in cosmic terms. This radiation is a relic from a time when the universe was a hot, dense sea of protons, electrons, and photons. As the universe cooled, it left behind this faint glow of radiation. Penzias and Wilson's discovery of this glow provided strong evidence for the Big Bang Theory, reinforcing the idea that our universe had a definite beginning. This discovery was a landmark moment, providing the first tangible evidence of our universe's fiery birth. Next, we delve into the 1970s when scientists began studying the abundance of light elements in the universe. This era marked a significant turning point in our understanding of the cosmos. It was during this time that researchers started to notice something intriguing about the quantities of hydrogen, helium, and lithium scattered across the universe. These elements, known as light elements, were found in proportions that astonishingly matched the predictions made by the Big Bang Theory. The theory proposed that in the wake of the Big Bang, the universe was a hot, dense sea of protons, neutrons, and electrons. As the universe cooled, these particles began to combine, forming hydrogen and helium, with trace amounts of lithium. The observed abundance of these elements in the universe served as a powerful confirmation of the Big Bang Theory. Yet again, the pieces of the cosmic puzzle seemed to fit perfectly with the Big Bang Theory. Fast forward to the 1990s, when astronomers made another groundbreaking discovery. The universe is expanding at an accelerating rate. This wasn't just a minor tweak to our understanding of the cosmos. It was a revelation that turned our comprehension of the universe on its head. This discovery came about when astronomers were observing distant supernovae. They expected to see these stars moving away from us at a slower speed due to the gravitational pull of all the matter in the universe. But instead, they found that these celestial bodies were actually moving away at a faster and faster rate. It was as if some unseen force was pushing galaxies apart. This unseen force, now referred to as dark energy, accounts for nearly 70% of the total energy in the universe. It's like a cosmic accelerator pedal, driving the universe's expansion. And while we don't fully understand what dark energy is, we know it exists because of the impact it has on the universe's expansion. The discovery of the accelerating expansion of the universe bolstered the Big Bang Theory. It suggested that not only did the universe begin with a Big Bang, but it's been expanding ever since. And this expansion isn't just happening at a steady rate, it's accelerating. This surprising discovery added another layer of complexity to our understanding of the universe's beginnings. Finally, we reach the 21st century, when scientists have been able to estimate the age of the universe with remarkable accuracy. With the advent of cutting-edge technology and advanced observational tools, we have peered into the farthest reaches of the cosmos, observing the oldest known star clusters. These celestial timekeepers have allowed us to estimate the age of the universe, providing further credence to the Big Bang theory. From radiometric age dating of meteorite material and Earth rocks to the use of the cooling of white dwarf stars, each method has its own unique charm. Yet, they all point towards a similar conclusion. Our universe is approximately 13.8 billion years old. This estimation not only supports the Big Bang theory, but also provides a timeline for the evolution of the cosmos. With each passing decade, our understanding of the universe's origins continues to grow, each discovery building upon the last. So why do these discoveries matter? Why should we care about the origins of our universe? The significance of these discoveries reaches far beyond the realm of astronomy. They fundamentally changed how we see ourselves and our place in the cosmos. By understanding the Big Bang theory, we've gained a new perspective on time, matter, and energy. These discoveries have also opened up new avenues of research. Scientists are now exploring how the laws of physics behaved at the inception of the universe. The study of the cosmic microwave background radiation, for instance, could shed light on the nature of dark matter and dark energy, two of the greatest mysteries in modern physics. Moreover, they've elevated our collective curiosity and wonder. Each discovery is a testament to human ingenuity and our relentless pursuit of knowledge. As we continue to uncover the mysteries of the cosmos, we are reminded of our place in it, a tiny speck in the grand tapestry of the universe.